Okay, number 10, another calculated problem. Given the function ln of 2x plus 3, write the equation of the tangent line to f of x that is parallel to this weird thing. Well, let's make that weird thing look a little bit better. How about 4y equals 8x plus 12? That looks a little bit better, but how about y equals 2x plus 3? That looks even better. I just realized that's the same as that. That's purely coincidental. Absolutely doesn't have to be that case. But here's the important thing. We know that we want it to be parallel to this line, which means the slope of the tangent line has to be 2, which means f prime of whatever value we're looking at, let's call it a, has to equal 2, which means we need to do a couple things. If I were doing this problem, I would do this. I would say y1 equals the natural log of 2x plus 3, close it. I would say y2 equals d over dx, which is math 8. You have to put the x in there. It'll give you parentheses, and you'll want to type ln of 2x plus 3. You could also just tell it y1 if you know how to get the y1 variable in there. That would work too. And then it's going to do bar x equals. You need to type another x. That is telling the calculator that you want it to graph the derivative of this function for every x value, which means it's going to graph the derivative function. I would do one more thing. I'd say y3 equals 2, because we want to find the spot where the derivative is equal to 2. So you need to find the intersection between y2 and y3. That's going to tell you the x value of the tangent line that will have a slope of 2. So do that. Graph that on a standard window. Should work fine. Zoom 6, zoom standard. You're going to get something that looks like this. Your first graph is going to be like, hello, I'm Floopy. And then your next graph is going to come in and be like, hello, I'm Doopy. And then your horizontal line is going to come in and be like, hello, I'm a horizontal line. I'm not very exciting. But what do we want? We want to know what is the x value, where the derivative, the second thing we graphed, that pink on mine, maybe it's red on yours, or maybe you have an old calculator and it doesn't look like anything except for a black dot all over the place. We want to find this intersection point right there. So second, calculate intersect 5. Make sure you're on the right graph. We want to find the intersection between y2, the derivative, so press down, hit enter, and y3, the black horizontal line. So hit enter once you're on that. Up and down changes between functions. Guess, well, there's only one intersection point, so it'll take us to it. And it says x equals negative 0.999999999. Well, it's trying to tell you that x equals negative 1. So we know that the x value of the intersection point is negative 1. So all we have to do is write the equation of the tangent line. So actually, I think the easiest way to do that is to just write it in point-slope form. Y minus, we need to find the y value of the function when x is negative 1. So I'm going to trace to y1, type in negative 1 for my x value, and I see that the y value is 0. So we got y minus 0 equals my slope, which I know is 2, times x minus the x value means x plus 1. And we're finished. Y equals 2 times x plus 1 is the tangent line parallel to 4y minus 8x equals 12 of the function ln of 2x plus 3.